again a program to show how processing is done with origin statements and N that has an address specification that has been written and with a statement that has EQU. I would still like to repeat, this particular program does no special function. It is just written to show how processing is taken for the various statements like origin, EQU and L1. Okay. Now, how do I generate an intermediate code for this particular statement? Now, when it is start and 100, like I mentioned, there is no intermediate code written except that the location counter value will be set to 100 in this case. Okay. Now, for start, I am not having an intermediate code written at all. Okay. Now, when it comes to ADS3, okay, this particular instruction is given address location starting from 100. Now A is a label, it appears okay as a label in our program, so I have to enter it into the symbol table with index 1 A. The associated address or the location counter value is 100. Now if you look at the program, it says ADS3. Okay, it says that you have to reserve for memory space for 3 words. Okay, so the length of this particular symbol is actually 3. That is the size. Okay, length actually means the size occupied by that particular statement. So you are associating 3 memory words, and that is why the location counter becomes 103. Okay, because in the previous statement you have given address. Okay, for 3 you have given 3. You have reserved 3 memory locations that is associated with this label A. Now after this, okay, the location counter value is incremented to 103. Now for when it comes to processing this statement, what you observe is that we have a label L1. So when you say L1 is a label, you have to enter it into our symbol table and put the associated location counter value. So in a symbol table you will enter 2, you will write L1 and you will write 3, and it occupies only 1 memory location. So it happens to have a length of 1, and the associated this is over here, and the associated intermediate code is this. So for move R, it is an instruction opcode. It's an imperative statement. The associated instruction code is 04. A register is 1, and B happens to be now a symbol. Okay. So if it is a symbol I have encountered in my program, so I have to put it into my symbol table. So 3B, I do not know the address. I have not yet found the length. Okay. Now coming back to how to write this, I will write it as symbol S, that is the class, and what is the index value? Index value is 3, so it is written as S03. Okay. Now then the location counter value is incremented, okay, to 104 because this instruction occupies only 1 memory location. Then after this you have an imperative statement IS. The add instruction code is 01. A register is 1. C is again a symbol encountered in your program, so I have to enter it into my symbol table at location 4. I am not writing an address. Do not get the length, and it is a symbol which is at location 4. So you will write S, 04. Okay. Now then the location counter value is incremented to point to the next instruction, which will be 105 because the length of this instruction is 1. Move M is an imperative statement, has the instruction opcode as 05. A register is 1, and D again is a symbol that you have encountered, which you have to make an entry into the symbol table. So you write 5 and you write D. You do not know the address, so you will write here symbol that is at location 5 in our symbol table. Then you increment and the location counter value becomes 106. Now I have encountered this statement. Okay. Now this assembly statement has a label. Okay. It has an address specification and it has a assembler directive called EQU. Now EQU is an assembler directive that basically associates this particular value as the address with this particular label. So what happens here is, what is the address of A? Now if you look at the symbol table, the address associated with the symbol A is 100. Okay, so here when you say A plus 1 is 100 plus 1, so it becomes 101. This 101 address location will be associated with this label D. Okay, so in our symbol table, check whether I have label D. It is there. I have to associate the address A plus 1 with it. A happens to be at location 100. Okay, so 100, A plus 1 is 101. Okay, and its length is just 1. Okay, and I am not going to generate any intermediate code for this particular assembler directive. What it does is, this becomes whatever is this value evaluates to, that will become the address associated with this symbol D. In our program, A is at location 100, okay, because we start at 100 and it is the first statement following star. You add 1 to it and D is now pointing to a memory location that is having the address 101. Now coming to the, we do not write any intermediate code for that particular statement. Okay. Now coming to the next statement, we encounter a label which is L2. Now if it is a label, I need to make an entry into the symbol table if it is already not there. So here we need more space in our symbol table. So we'll extend the symbol table here. Okay. At location 6, I will enter L2. And what is our location counted value? It is 106. Okay. Now, and it occupies length 1. Okay. So at 106, print. Print is an imperative statement and it is having an instruction opcode of 10. Okay. Now D has come. Okay. D is a symbol. Okay. I don't have the first operand. For second operand, it is a symbol. See whether D is already there in the symbol table, get its index value. If it is already there, if it is not there, you will have to make an entry. But in our case, D has already been entered and associated value is 5. So it is symbol 5. Now what happens to when you encounter a statement origin A minus 1? Okay. Now after it has done processing of this particular statement, it will increment the location counted by size, which obviously is 1 in this case. So the location counter value becomes 107. Okay. But when you encounter a statement like origin, start and origin are used to give values to the location counter. So when it encounters a statement like origin, what it does is, it will, whatever value is associated with this origin keyword, that will be made as the new value of the location counter. Okay. So if I have a statement like this, origin 100, then, and if my previous value of location counter was 106, after executing this statement, location counter value becomes 100. This is a constant that is there. Okay. Instead of a constant, you can have something like this, A minus 1, where it is an operand specific, where it is an memory associated or given the name A. So take what is the address associated with A. If you look at the symbol table, it is 100. So 100 minus 1, 99. So what happens is, our location counter value now changes to 99.